stomping in. Woo! All right, guys. Are you here?
Yes.
He's here. Are you here?
Yes.
Awesome. Which of you are developers? Hands up. Which of you are something else? Hands up. Nice binary test. We go with that. So, welcome to this room, which for this hour will be renamed Retardis. But then after 12, it will be TARDIS again. And this is about selecting Azure Platform as a Service tools when you are thinking of building some kind of a custom project, a business application, whatnot. I'm Sakari Nahi. I've been developing .NET since 2001, Azure since 2011, CEO at Azure, this company where we build Azure. We have this Ikkuna studio with Jouni Heikniemi podcast, and then please join Finland Azure user group. We have like over 10 events yearly, and now we have something like 1,200 members already. So just put to Google Meetup FAUG. About Azure, we are very experienced people, average 14 years of experience for our experts. 32 out of 34 people in the company are experts, and then all we do is Azure. The satisfaction is our customer satisfaction from last month, 4.5 out of 5. We are okay with that. So this is the first tool we had collectively, all of us amoebas. Like we had a rock, and now we got this. So that's something. I know how to build a rock. I don't know how to build that thing. But now this thing will be this thing. You probably heard about Microsoft dropping stuff in the ocean for the cooling purposes. So they are like pretty well along in the process of building an underwater data center. I don't care about that otherwise, but you know, that would be a nice way to get a data center in Finland. Just drop one in front of Helsinki. Boom, done. And this is, of course, what you do with the cloud. These are some Olympics, and there's a bunch of viewers, bunch of videos, and the public cloud is the backbone, the platform to make it able to scale so that this kind of traffic is possible. Nobody, Netflix has and Facebook has, but these only big boys have their own global infrastructure now. So let's dive into Azure Platform as a Service. This is old, I guess, an Azure product map with all kinds of products. We'll be focusing on these that are red. So if you're thinking of building something custom on Platform as a Service, there you have like a bunch, I don't know, 10, 15, someone count how many products there are. But if you know those, you are set for 90% of your cases. Another kind of map with these same boxes. This seems kind of easier. So there's Azure Functions, web apps, API apps, which are basically web apps. So 2 boxes for no reason really. Search, some databases, document DB, some storage more, and then we have the security things and messaging things. And that's what it is, and that's where we're going. Before we go there, I want to say this one sentence. You can build it with Platform as a Service. Now, this is something that wasn't the case a couple of years back, right? There was all kinds of incompatibility issues, like you had a solution somewhere with SQL, and the Azure SQL wasn't up to date or on par, or there were some other issues. The reasons that you don't go Platform as a Service now are basically these. You don't have the expertise. There's not enough expertise in your area, right? You can't get, good guys. Legal or regulation thing. There's not that many legal things, at least in Finland, because the data is in EU, but it might be a regulation thing or a contractual thing with your client. You can't go to cloud because you promised your clients we are not going to cloud. It might be political, and I don't mean like sote political, I'm meaning inside your corporation political. Somebody thinks we shouldn't go to cloud because cloud is evil and you can hide. Strategy, it might be your strategy not to go to cloud. Platform lock-in, you might be afraid of Microsoft or Amazon, and it might be sensible as well. Or it might be time critical. So the last thing is technical. All of these other things are some other things, but the last thing, if you need to direct some activities in your factory every millisecond, don't put your compute in Amsterdam, right? It makes sense. So public cloud there, very bad. Otherwise, pretty much good or okay. So there's a lot of different tools. This is some kind of micro precision saw. and don't get me wrong, I've never used any of these, but that's pencil-sized. And then there's this guy, which is the biggest saw ever, I guess. And in Azure, it might be the same tool, right, that can do both of these. So it comes to your expertise on selecting the tools and using them in a correct purpose. You found the tool, but it's not the correct tool, or of course you can make your own, which is always a good idea. You ask me, I'm a developer, it's a great idea to build your own. And then you can use your tools in a way that hurts your teammates, or might hurt, or are scary in some way. So what's the content of this talk, now that we have the retard jokes are over? I'm going to walk you through a concept, a business application that I bet many of you have met in some way. Some segments or components or functionalities in this concept will be familiar to you, or you can imagine them. And then we will decide on storage, compute, messaging, identity, and monitoring how we build it. So the concept is called Order Master, and it's about sales orders, right? And that is the UI for it right now. It's a box. So you can log in, you get your face on the upper left, and users are salespeople and clients, so internal and external people in the corporation you are building this to. The users can search for purchase orders in free text. They'll be like, oh, make it Google, make it Google. And you're like, sure, I make it Google. There are millions of meaningfully diverse orders, right? So this company you are talking about, they have more than one product, like almost all companies do, and these products are in some way similar. They have product family, they have product ID. If you're lucky, it's global, it's unique, and so forth. But then they might have some parameters or attributes that are diverse. They don't match with other product lines. And the orders also, in addition to details, they also have sales data. So to order, you can relate or connect accounts, contacts, activities, and it contains binary objects. And then there is report generation, which, as you well know, if a client comes and he's like, oh, I want to know what we ordered during the last year, click. It's not going to be a report that's pre-generated. Sometimes it is, sometimes it's not. We'll see. So this is the concept. And pretty familiar to many of you in some senses. Search, reporting, searching for items, showing details, showing pictures or documents or whatnot. So looking at that architecture, we know that we have mobile and browser users. So we can fill that in. And then we have two source systems. I know this is a utopia that we would only have two source systems, but let's imagine that we only have two source systems. We have order source for orders and related sales data, meaning that it's CRM plus transactions. So probably it's like SAP and Dynamics or something at your place. And then there's a document source that contains binaries, images and stuff like that. So we have two sources. That's what we know. And we don't know much else yet. We know from the concept, we know that much. So what are we doing? We are going to walk this through by selecting the storages first. That's how I do it. Some of you might not do it that way, but I'm old, so that's how I go. And in storages, you are thinking if the data is relational. Is the data binary? Is it unstructured? Do we need caching? Do we need analytics? Do we need free text search, right? Then we choose compute. That's where I go next. We think of control. How much control do we need? Do we need to be afraid of platform lock-in? Do we care about the infrastructure, the scaling, the architecture, and how much management do we want to have? Well, that's the other side of the coin for control, of course. The more control, the more management. Then we decide on messaging. If we have compute nodes, they're going to communicate with each other, right? So we gotta know queues, publish, subscribe, routing, persistence, ordering, security. Do we have sessions? Do we have acknowledgements? How do we do transient fault handling? All of that stuff. Identity, we have external and internal people. How do they come in? What's the governance? What are the regulations? Do we have single sign-on? What are the protocols in use? And what's the current identity and access management? And the last thing, which is also always last thing, the monitoring. You have something in production. Oh my God, we need monitoring. You know, logging, debug data, and all of that. Dashboards for service desk or help desk. So we're going to start with the storages. Storage. The first question people come to, especially people who've been a long time in the industry. How many of you have more than 5 years of IT experience? Hands up, 5 years. Like most of you, cool. So most of you know that 10 years back when you build an application, it was a web server, Apache or IIS, and then you had a SQL, and then you had files on some hard drive, right? So, and that thinking still persists when you are thinking of building a custom project. You think, okay, what's our database? What's the database? What's the main database? And the answer to that is that you won't have in the cloud, probably, if your application is even a bit more complex, you won't have only 1 or 2 storages. You will have more storages. And I even found a word for it, polyglot persistence. Awesome word. So that's the first thing. Forget the main database and go with whatever data you need. The purposes are done. Is SQL dead? No. This is something that's I don't know, I think this is a lesser thing now. I think it is a bigger thing like 3-5 years back when people came to me and said, hey, it's not a cloud app if it has relational SQL. It needs to have a NoSQL. It can only be a cloud app then. But that's of course not true. SQL is not dead. SQL has nice features that NoSQL hasn't, and it scales, well, in Finland at least, it scales in 80% of the 90% of the cases. And we understand SQL. Many of us don't understand the document DBs or NoSQLs well enough. So everything's on the table. Like we came to this cloud era. Can we drop some things that we used 10 years back and not think of those? We cannot. And that's very awesome because there's just more and more and more stuff packed in all the time. The options, relational SQL, the first column is the thing, the second column is the Azure product that provides this Azure SQL, and then some lines. Relational SQL, it has structure, the data has schema, and it has transactions. It's well understood. The performance is good, and it's well understood. And of course, if there's a DBA here who says that developers don't know anything about optimizing SQL, that's also true, but developers know quite a lot about indexing and the basic performance things. So the issues with SQL is that there's no horizontal scaling. Like if you have a SQL database, you can have a bigger hardware, more performant hardware, but if you're thinking of scaling it to hyperscale, it's not easy to have like 5 machines or 10 machines globally that have the same SQL because the tables don't work like it. And the disassembly is costly. So when you get the data into SQL, and if you're familiar with it, one data entry is in multiple tables, right? One has my address, one has my details, one has the school I go to or whatever. And assembling those together with joins to build application code object is costly. So this is used much in CRM, CRPs, all of that relational data. Key value is the next thing. So it's offered by Azure in Cosmos DB, Redis Cache, Azure Storage. It's hash and value, so a key and a bunch of things tied into it. And it's fast on lookup if you're looking for that ID, but it doesn't have indexing. So if the key is Sakke, and you search with my surname Nahi, it will be slow. But if you search with Sakke, it's fast. It scales nicely. So because it's just entries, you can scale it to hardware. Azure can do that for you in hardware level, and you can scale it with duplicates. This kind of data is like, I don't know, 20 euros a month per terabyte in Azure. So if you have 100 or 1 gigabyte of data, you can duplicate it with different keys. So if you have 2 different ways of querying for data, duplicate it once, it doesn't cost you any, it's fast and nice. So think about it. Caching, sessions, dictionaries are pretty regular here. Anything with a single ID or 2 IDs, or maybe even 3 IDs. Triplicate the data, that's fine, that's how you should use it. Then we go to NoSQL, Cosmos DB, which is of course a multimodal database. So it has the Azure Table Storage API, and it has the Document DB, and it has the MongoDB, and it has Cassandra, and it has all of these different ways of using Cosmos DB, but the strategy beneath those, they are the same. A document is a collection of fields. So meaning that if in Excel terms, in SQL database, you have multiple sheets or tables that have like one sheet has everybody's name and second sheet has their working places or something, then in a document, it would be a single JSON or text file that has my information and the place I work in. So there's no relations. And it's stronger on queries than key value. For example, Cosmos DB indexes every field automatically. That's actually the first tip I give you. Never index anything. It's default indexing everything. Just drop half of that and the performance will soar. So do that. Okay? It scales better than SQL because the documents are atomic, right? The documents have no relations to each other, so it scales pretty nice with multiple hardware nodes. What's nice for developers, why NoSQL has this huge following of developers, of people like me, is that it matches the application, right? I have this application where I have a user or order, like in Order Master, and the document would be order. I just go to database, I ask for an order with this ID, and it returns the whole object. I don't have to do complex queries or joins like I have to do in SQL, and that feels easy to me. That feels very approachable. There's no schema, so you can have anything there. And it's useful for products and articles and isolated objects, things that don't have as much relations. Then there's graph in Cosmos DB as well. So graph is a thing where you have nodes, and they have edges beneath them. So an object that have relations to other objects, and it's for things where relationships are first-class citizens. So it's good for organization charts and social charts and graphs and all of that stuff. So basically, maybe in a SQL, I would have me and then, for example, Juhani Vuorio, who's sitting right there, and it would be two people, and we would have a relationship that would be just a foreign key, right? But in a graph, it would be us two, and the relationship would be as important as us two. So the relationship would have information like our relationship is warm and cuddly and stuff like that. Then there's search. In Azure, it's Azure Search, and it provides text indexing and aggregates and all of that stuff. So for catalogs and content search, article search, it's pretty nifty. It's actually one of those products, like for example, I'm not always happy with Cosmos DB. Like if you come to me and you're like, hey, we have some performance or throttling with Cosmos DB, I'm like, sure you do, everybody does. It's like, unless you pay like, a lot of money. So there's real art into making it good, and we're going to talk about it soon a bit more. But search is one of those products in Azure that just works. So Azure Search is pretty good. So next time, instead of setting up your own Elasticsearch cluster or whatnot, think of putting this up in 5 minutes and defining the index and uploading the documents, and that's done. It has a lot of nice features. And binary, the last and the easiest. Blob storage and data lake store. So you have images or documents, just upload them there. Nobody cares, it's structureless, and then you can call for them. So now we know the options. What are the no-brainers on selecting the storage for our order master? So binary data, blob storage or Azure Data Lake Store. That's no-brainer. Pick data lake if you want folder structure, because blob storage is just key and value. If you want folder structure so that you have, I don't know, an account name or a client name or your name and then a bunch of files related to you, then, and you want to maybe change the folder name later to someone else that, hey, you are now responsible for these, then folder structure is good. Because in blob storage, you would have to rename every file to change the key if that contained this kind of multi-part key. It has finer access with POSIX style, and it's good for doing analytics because it's HDFS, so it's Hadoop file system natively, that Azure Data Lake Store. Now, Azure Data Lake Store, a couple of weeks back, Microsoft announced Azure Data Lake Store Generation 2. How many of you are familiar with Azure Data Lake? Hands up. Awesome, not that many. So let's not talk about that, but the thing is, now from Generation 1 to Generation 2, it's a totally different product. So if you are working with Data Lake now or you're thinking of going there, pick Generation 2 because it's cheaper, but then Azure Data Lake Analytics is not on top of Generation 2. Thank you, Microsoft. They both start with Azure Data Lake, but the store Generation 2 is not compatible with the analytics part. So So then you don't have that tool, and it's not clear if it ever comes. So yeah, think about that. Cache, use Azure Redis. Use Redis Cache. Everybody uses Redis Cache. Use it. Persistent Redis is 340 euros a month. That's a lot in PaaS terms, but regularly it's like without persistence, like how most of you use caching, that it's not persistent, it's 30 euros a month. So persistent is expensive. And then if you use Cosmos DB, expect to use caching. And then search. If the client, the businessman, the owner, the boss, the product owner, whoever tells you, hey, we need Google like search, go with Azure Search. It's good. So then we come to hard bits. Those were no-brainers. The hard bits are SQL or no SQL, SQL or document. And then key value and graph are there like in parentheses. But usually it's between SQL and no SQL, the hard question. Now Cosmos DB, it's easy to decide if your need is such that you need a global multi-master right. Multi-master right means that if you have business in Australia and in the United States, and you need to have people in both locations working with the same data set, same sales information or order or product or whatever, you can just toggle Cosmos DB to be multi-master right and then select the instances so that they are in Australia and they are in the United States. And then it means that these peoples who are very separate geographically, they edit the same file. So they can both write at the same time to same JSON document, which is under the hood, and it will just work. And if you think of that, if you have this need, like I want to see the R&D team who says to business that, hey, let's build our own global synchronization and replication on SQL clusters, instead of just plugging this on. So that's an easy decision. But it can be costly due to partitioning. And the partitioning is the part that's difficult with Cosmos DB because it partitions forever, meaning that it has some requirements so that it can partition infinitely. So here we have, on the right, we have this Cosmos DB database, and there we have a collection. And in Cosmos DB, you define the performance, the throughput of the collection with request units per second. Now your first thinking might be that, hey, we need to understand, request per second, if the browser user makes 5,000 requests per second, that's a lot of requests. But it is not requests per second, it is request units per second. Request unit, one request unit per second is one query for a 1 kilobyte document by its ID, with its unique ID. And that's one. So anything else, so basically all of the queries you send, are more expensive. How much more expensive? Nobody knows. Nobody knows. There's no way you can. It's like, some people come to you and they're like, how much will this cost? And then you're like, I don't know, better call Sakke. Sakke spoke about Cosmos DB. He probably knows. And I'd be like, I have no clue. I don't know. So of course, once you use it a couple of times, you have some ballpark. Maybe you can do this with 2,000 or 3,000 reviews per second or something. But the thing is that separate queries, depending on the query complexity, can be between 1 and 200 request units. So, if it's 200 every query, then 5,000 reviews is not much. And that's already hundreds of euros a month, 5,000 reviews per second. So how it works is that when you partition Cosmos DB, you choose your partition key. Because your document that is stored there, it's a JSON file, so it's just a text file. And you say that, hey, the partition key is just surname or city or tenant or address or whatever. And that's how Microsoft divides those into logical partitions. Now, the recommendation is that there are thousands of partition keys, and now you'll soon come to understand why. The thing is that you can, of course, like if you have millions of documents and you choose ID as the partition key, then you have millions of logical partitions. And that's fine. That's, it can handle millions. There's no theoretical limit in Cosmos DB for the amount of partition keys. So this sounds scary to a SQL person, but there's no limit, so go nuts. But the thing is that beneath logical partitions, the logical partitions are stored in physical partitions, which are, of course, machines, right? They are servers in the cloud. And there's no way you can control those. And if you go check out the documentation and stuff, Microsoft isn't very, I think the documentation of physical partitioning on Cosmos DB is a bit hazy. It could be better. It could be stated more upfront, because this is where the issue comes. The issue comes when two logical or many logical partitions are in same physical partition, right? And you buy and you pay for 5,000 RUs per second, and you have 5 physical partitions. It means that there is 1,000 request units per second in use in a single physical partition. So if your logical partitions that are the hot path, the ones that are queried the most by the application, if those are stored in the same physical partition, the throughput will only be 1,000 RUs per second, because that is the physical limit for that physical partition. And that's the reason why your partitioning key strategy is key in making this working. If you only have a couple of keys, then it is likely that they will end in same machines, and if 80% of your requests go to same machine, it throttles. And then Cosmos DB returns 529 or something, and then your application is like slow as hell. And this is the difficulty. This is very annoying. So how can that be fixed? Now, busy physical partition is what I talked about. Cross-partition queries means that you make a query that spans multiple logical partitions. Then Cosmos DB needs to ask all physical partitions, and that's, of course, expensive. Easiest way to fix this cost issue is with caching. So have a Redis or have a Azure search, couple of hundred a month, and then search for the data from Azure Search, get the ID from Azure Search, and query the details from Cosmos DB with the ID. And then it's fast. It's blazing fast. Cosmos DB is very fast when you use it correctly, but it's just so very hard to use it correctly. That's the issue. The harder way to fix the cost, but in a sense it might be more elegant in some choices, and you don't need Redis and Search, you can just be in Cosmos, is to use specialized collections to manage load. And this means that instead of having a single collection where all of your data is, you have multiple. You have one for ingesting the data. Your data comes into Cosmos DB ingestion collection where you have your incoming data. Then you have Azure function, which is a serverless component similar to AWS Lambda, that is triggered by the change in data, and Azure function makes some things and stores it into smaller collections that are optimized for a certain type of query. You can do this without the Azure function, which is of course another Azure product, inside of Cosmos DB with Cosmos DB stored procedures. So Cosmos DB has these SQL-like stored procedures that are run inside of Cosmos DB and that do not generate more costs to you. So then you have these here, person by name, person by postal code, and orders. So 3 types of collections where your queries go whenever you need that kind of feature, and it stays fast, and it stays cheap, and it stays performant globally. Because when you think of global issues, it is not that easy to have a global Redis or a global Azure Search. So there, this kind of scheme, this kind of architectural data pattern is what you want. And then, the reads come there. And the other option for NoSQL is SQL. So if you need strict transactions, transaction now, it's done, go with SQL. It's known and understood. You have people that know SQL, so you're going to do less mistakes, you'll be faster, although you'll be cursing ORM and Entity Framework, of course, but you'll still be faster. Oh yeah, I can't remember the points because I can't see the next slide. It's over there, so I'm just pulling stuff out. What is the big difference with, to me at least, when you think of like, okay, you build an application and then it's in production for 5 years, right? So that's a big thing. That's a bigger, being in production for 5 to 10 years is a bigger thing than building the application. So, and when something is in production, you get updates. You update the application. You do hot fixes. You need new features. The world changes. The business changes. It's sold. Whatever. Something happens, and you need to migrate the SQL, the database. You need to have from version 1 to version 1.1. How do you do that in a NoSQL? Because in many cases it's done by batching or some, custom code or whatever. It's like that's one of the things that are not there yet on NoSQL. The tooling for migrations during production. In SQL, that is very well known and understood because the data has a schema. You can just change the schema and then you can make the changes to the data according to the schema change. Now, people say that NoSQL is faster and easier, and it kind of is, in a sense, but when you go to data validation and the validation of relationships and the version updates, that code, in the case of NoSQL, is in your application code, right? That validation is somewhere. You can't just accept any data quality. So there's going to be data validation. Do you want to let your database do it? Or do you want to code it in your application code? I don't mind. Both have their purpose, but let's just not say that SQL doesn't have its place, because it does. So, to architecture. Relational sales data in Azure SQL. Makes sense. We have accounts, contacts, leads, opportunities. They are very CRM data. They are in SQL, and they are related to our orders. Then we have the Cosmos DB for the dynamic orders. We have this diverse set of millions of orders that have, all of them have their different, different metadata. So you don't want to write a schema in database for hundreds of different kind of products. You just want to have that available with the product ID or date of purchase or contact or account. So that data you will have in Cosmos DB. Suddenly you have 2 databases. Then we have the binaries and raw data. So the data that we haven't changed yet, that we will store in data lake. The binary, the pictures and documents are, of course, for the application, but the other stuff, the raw data, is just there to cover your back. Something went broken somewhere, you want to see what was the original file the application received from SAP, whatnot. So now we have 3 databases. Then we wanted to have the Google search, right? The business side, they needed the Google search for the orders. There were millions of orders. I want to search everything purchased by Leon or in France, whatever. You have it there. It's cheaper. It has all kinds of GPS, geo-profiling things. You can search for things near Paris or whatever. It has all of those built in. Do we have more? Yes, caching. You want to cache. You want to cache stuff in Redis. That's just, so there's a lot of things, but that's not a lot of money. Azure Search is 200, so that's something. Redis Cache is $30. Cosmos DB, depending if you build it right or not, it's between 50 and 700 euros. And Azure SQL is between 50 and 100 and 200 maybe, depending on where you're going. And Data Lake is 20 euros per month, per terabyte. So it's a lot of databases, but it feels bigger than it is. Compute. Now we have our data layer. Let's go for compute. How many of you have seen this classic picture of cloud, going from on-premises to cloud? Hands up. Like, not everybody. That's very surprising. Well, this is old. Don't look at it. This is the new one. So you start with on-prem, where your scaling unit is your hardware, right? You have your own data center. You're going to go, yeah, we need a new machine. And then you scale by buying new machines. Then you have the infrastructure as a service, something that Amazon has been doing longer than Azure, and Azure is doing fine right now, and all of them do. So there you order a new virtual machine, and you manage the operating system, right? That's your unit of scale. You need more performance, you get more operating systems. Then this is new, this wasn't in the previous picture, containers or containerization as a service, right? That's something. How many of you are interested in containers? Hands up. Yeah, that's a lot of hands. So containers, there you manage your admin, your containers. You have your container registry, you have your container images, you have your container history, and then you have, then you deploy them, and then you do the reverse proxy and networking and stuff like that. But you manage the containers, which leaves the runtime inside the containers to be managed by you guys. Then you have the platform as a service. So containers are still without platform login, right? Then you go platform as a service. It means that Azure or Amazon or someone provides you with their tool. So going that step forward, it locks you into this vendor in a sense, depending on the tool, very lightly. In the case of Storage Blob or Azure Search is actually a light integration, even though it's a specialized tool. Or very heavily, like in Azure, for example, Service Fabric programming model is quite heavy, and so forth. But there you don't have to worry about runtime. You don't spend any time on defining the runtime for any of that stuff. You just worry about the application. And the last bit that is meaningful to me, is the functions as a service. So there your thing scales by having functions, these serverless components, Amazon Lambda, Azure functions, and these things that you get a HTTP request or a scheduled thing, it runs the code, it's 200 lines of code, it does something, it sends a message somewhere, and then it dies. And then another Azure function picks the message and starts doing something, and then it dies. And it doesn't cost you anything when it's dead, of course. So that's functions. But applications are gray there. It scales by functions, but if you have hundreds of functions, but they don't make a cohesive application together, what's the use? There's no use. It's meaningless. So you gotta think about the application. You gotta have the concept there. You gotta take care that these 100 functions work together well, even if it scales by functions. And then you have software as a service. You buy Salesforce, you buy Dynamics, and they are their own fully fledged applications that you don't need to change, but every corporation still changes with hundreds of thousands of dollars. So SaaS is, I don't know. Personally, I think it's a bit of a misnomer, but still it's life. There we go. That's cloud now. And right now, the most action is like, before it was infrastructure and PaaS kind of something and going from on-prem to IaaS. And now the edge is where the discussion is around containers and around serverless, right? If you follow the thing. That's where people are like, oh yeah, this is the best. That's where the fanatics lie, this is the best for everything, always. So compute, infrastructure as a service. Now, I live in my bubble where I hate servers and hardware, and Azure has been up for 8 years, and we put up 2 VMs during that time, and I wish it stays at 2 for the next 7 years as well. So, but if you want control, then you put up virtual machines, right? You want containers, you want less control, but you want still a lot of control. Then you do containers. There's Azure Kubernetes service, managed Kubernetes. Kubernetes is a clear winner on the container orchestration, battle. From my point of view, if you disagree, please come see me at the stand. Service Fabric Mesh, which is Microsoft's own product for orchestrating containers. It's a bit different. It offers some capabilities Kubernetes doesn't, but then Kubernetes has a lot more expertise. So there's a lot more people who know Kubernetes as opposed to Service Fabric Mesh. Azure Container Instance, it runs a container, and App Service runs a container. Platform as a service is app services on the compute, and then that's basically, there are a lot of different app services. It's a big thing, but you can have your code running there. And then there is Service Fabric, where the programming model is very platform as a service, but you have to set up a cluster to run it. So I don't know where it goes. It's like a hybrid. But it's a microservices framework if you're interested in those things. But you can do microservices. Microservices just meaningfully split functions or use cases, business use cases that can be deployed by themselves without affecting other functionalities or use cases. So you can do it with app services, you can do it with Kubernetes, you can do it with Service Fabric if you just say microservices. You can do it Akka.NET and Orleans, and there's a lot of options. And on functions as a service, there's Azure Functions on the compute in this talk. So how do you pick and choose? Are you thinking of lifting something classic to cloud? Or are you building new stuff? If you're lifting something classic, are the requirements from the people who demand this of you, are they saying that, hey, I just, it needs to be there in a week? Of course, they always say that, but then you're like, does it need to be there in a week? Yeah, it needs. Are you sure it needs to be? Yeah, it needs to be. It's going to be 100% more expensive if you do it in a week. Oh, it doesn't have to be there in a week. But lift and shift, or do you need to optimize it for the cloud nativity, or so that it's more scaling, it's more structured, it's more cost effective? If it's lift and shift, containers are an excellent choice. You can have your classic runtime in containers in pretty many cases, or you can just have app service, which is, like I said, a web app, web browser, or stuff like that. So you can just lift your Java application and run it inside app service where the Microsoft takes care of your runtime. And if you're looking for optimized, so they're like, oh yeah, let's improve this thing so that we learn something from the cloud while we do this classic lifting. Then you go to new stuff, right? Then it's just the same things need to be thought about. And there you gotta think of if it's a real microservices application, is it a modular monolith, or are they short-lived processes like integrations? There's data coming somewhere, done, transformed, boop, done, not anymore, so that's short-lived. Real microservices, I put real there because I think microservices, there's a lot of talk, well, I'm a technical guy, so in my bubble again, there's a lot of talk on microservices technically. So what is the approved microservice framework, or does it have to be Kubernetes or whatever? And really, what I see more is that microservices are just, the concept, the architecture concept isn't a fit. Like if you think of Amazon experience, and you go and you search for a product you want to buy, that search is a microservice. Then you're like, I want to buy this. You click a button, and then you go into another microservice that's buying. And then the search app just sends to the buying app service the product ID, and maybe if you're logged in, your information. But the buy microservice demands your login capability. And then after you purchased it, Visa, MasterCard, all of that has been paid, then the next step is logistics, sending the stuff to you physically. And that's its own microservice. And that microservice just gets the information from the buying process about the product, and then your identification that this person has purchased this, and then it asks for your address and does the shipping cost calculation, all of that stuff. And that's, of course, a web shop. But the modular monolith is just a web shop that all of those are very tightly tied together, even though they might be well coded, so they are loosely coupled. But when you think of microservices, people start thinking of, hey, let's have this microservice for buying, and then this microservice for searching products, and then they share a database or something, and then it's just a fragmented modular monolith. It's not a real microservice framework as such, or architecture as such. So that's my thing with the real microservices. So if it's real microservices, Azure Kubernetes Service might be a good choice, Service Fabric might be a good choice, or then you could just have app services and functions, which is a platform as a service, and functions as a service platform option or solution for you guys. So if it's a modular monolith, so all your code, your application is here, it's all one, and then you just, that this application, the concept, it's cohesive with the boundaries such that it can be built as a modular monolith, which is a good choice, then go with app service and functions. That's your platform as a service. That's the choice you will make if you go platform as a service on a singular application. And if you build modular monolith well, and you are thinking of microservices, it's not that bad going from modular monolith to microservices, because the boundaries are well defined, the contracts are well defined, so that's what you do. And short-lived processes, functions. So now here, of course, we could add logic apps, which are these more business-friendly short-term computes that are meant for integrations from Azure's point of view, from Microsoft's point of view, and that's true. What I've seen is that when we are talking about integrations that really require compute. So there's some transforming, or there's large files, and you need to look at every row or something. Then logic apps are just, they don't perform that well. Functions are more robust. But logic apps are easier to build. So maybe I should add logic apps here as well. But I like functions more, so it's functions. Architecture. We have a web app that hosts our website. There's the API. It doesn't necessarily host our web app. It might be elsewhere, but at least it hosts the API that respond and get the queries from the clients. And then we have Azure Functions, because we had the report generation, right? So whenever someone says, I want a report, and we know that it's very compute intensive, we want that computing to happen in the Azure function, not in the API, because we don't want to eat resources from the API when it's supposed to be responding to queries. Then we have an Azure function that is, I don't know, launched every night or something, and it gets data from the order source. And then we have a data factory, which is this ETL-like integration tool in Azure for doing SQL copies or file transfers or stuff like that. It can orchestrate and command stuff like Azure Databricks, so it has some connections to AI and analytics as well. But then these guys, of course, talk with the data layer. So Azure Function gets data from order source, splits the data and stores it in Cosmos DB for the orders as documents, and to Azure SQL for the sales data, for the relational sales data. That was compute. Now we have chosen our compute pieces. Now the rest of our segments in this talk are faster. Messaging. We need to somehow tell the Azure function to do things, to do this report generation, right? It needs to wake up when we need a report. So messaging is the thing that comes to mind then. So choosing the messaging tool in Azure Platform as a Service or Azure Cloud is again, an exercise. There are multiple options, and these are the options. Storage queue is when you think this. I just want to make sure everything is processed. So it persists messages in a queue, lets someone pull message and process it. So if you just want to have a place where all of your messages are, then that's fine. And it's cool because, over 80 gigabyte messages or queues are supported as opposed to message bus. If you're familiar with Azure Service Bus, then that doesn't support larger queues than 80 gigabytes. So if the messages you are sending are not really messages but are like full-blown big documents, then storage queue might be the way to go. Azure Event Grid, that's fast, and it's cheap, and it's scary, and it's such a system that it gets events, so I can tell Azure Event Grid that order made. Someone ordered something, that's an event, new sales order. And then it pushes the topic to subscribers. So there are Azure functions or some other compute node that's interested in a message that sales order has been done, that there's a new order, I want to do something, I want to do logistics or whatever. And this guy sends that information as an event to a subscriber. Now what's scary about this is that if this Azure Event Grid that can handle, 10 million events a second, if that gets a 10 million events per second, it just pushes all of those into your application. So the developers and architects in the room, when you're thinking of an application and you have some kind of a web app or a host or something that receives messages from Event Grid, think of the peak situation when you have the full load on. If you have 100,000 users or something is scheduled, the Azure Event Grid will just keep on sending messages, and if your processor doesn't scale, it will crash. And then it will get back up again, and Azure Event Grid has persisted the messages it couldn't send, so it crashes again, because then it just sends them, all the leftover messages again to the compute. Azure Event Grid is getting a lot of new features all the time. So now the subscriptions can filter by event payload, meaning that if there's an event, a new sales order, and the event says that it was a 1,000 euro order, maybe it is routed to a different place than an order that is below 1,000 euros. So there can be this intelligent routing in Azure Event Grid as well, as long as you're aware of the force-pushing nature. Azure Service Bus is the full suite for business process. So if you have a process that you are trying to, that is dependent on other messages, then Azure Service Bus is the way to go. Events are one-time happenings in Azure Event Grid. Service Bus is a full suite for these messages that need to come in order, need not to have duplicates, and so forth. It can be a queue or topics. Just means that topics are something that, hey, I'm interested in a topic of new order, while some other app is interested in a topic of new employee. It has first in, first out, transactions, fault handling, all kinds of stuff. So use that if you need that. Sessions, policies, so forth. And then we have event hubs, which is this ordered event streaming. It can also ingest or receive millions of messages per second. So this is usually used in IoT cases where the cloud only wants to receive messages from the IoT devices. There's no two-way communication. But here you need to be aware of the racing conditions if you use event hubs for getting your messages into cloud. The situation here might be something, you have a processor on the right, and on the left you have this event hub partition that has all of these messages. Now, green messages and black messages, they're all messages, and the processing thing has taken the black messages. And now someone comes and asks, hey, what's happening? Where is the red message? Why it hasn't been processed yet? The red message might have a large order or something. And then you check as a developer, hey, this red message is very small. It's just 1 kilobyte. It should be processed. But if the yellow message there is bigger message, it needs a lot of compute or processing. You might not be checking that in your debug phase, and then you just might not notice that, hey, that this processor is still processing the previous message. And because Event Hubs processes everything in order, it means that the red message won't be processed before the yellow one is processed. And that's why the red message might be late, because of a message that is unrelated. So be careful there. Can shoot you in the foot. So architecture, we're going to put event grid between Order Master API, the web app, and the Azure function that does the report generation. So the API sends a command event to Azure function processor through the event grid. And then, for the hell of it, added API management, because if you work in a corporation or for a corporation, they have some kind of a plan for an API management. They might have it or whatnot, and if it's there, then you of course need to publish your Order Master API through the API management for your clients. And there's the rest of our architecture. Starting to look like an application already. Identity, one slide. In cloud, you have Azure Active Directory, and then you have the B2C. So Azure Active Directory is good for enterprise applications where you have internal people logging in. Users are invited as guest users. So external users, if they don't have an account in your corporation already, you invite them as guest users. You can use any email, and then they get access to your Azure Active Directory, and then you can give them permissions to access your application. Business-to-business single sign-on is easy if the other party has Azure AD or Office 365. In Finland, almost everybody has Office 365. So in Finland, it's super easy. In other countries, this screen went down, cool. In other countries, it's a bit more, it might require some work. It's usually cheaper than expected because companies have it in their Office 365 already, and you can get free guest user accounts at a ratio of 5. So if a corporation has 1,000 users, they can invite 5,000 users without additional costs. The other option is this B2C. It's a different offering, even though the name is pretty similar, and it's good for products that are for diverse set of consumers or users. And that's, you don't invite people into those apps, people register themselves into these applications. It can provide custom policies, which is a nice feature in B2C, meaning that beneath B2C, there can be other identity providers that can be provided through B2C. And it's visually more configurable. It's meant for those of you who are building applications in your startup or ISV, meaning these SaaS applications. So in this application, we chose to trust Azure AD because this is an enterprise application. Salespeople log in here, right? And then we invite external people to this custom application who are the clients. And we configure into Azure AD, we configure all of these applications that have compute so that we can, in Azure AD, we can define the trusts between these computes. And then we know that there can be no middleman attacks or someone goes in the middle because Azure AD makes sure that only this application can access this API or vice versa or whatnot. And that's not anything to do with the user authentication or authorization. It's about the application trust. And that's a nice thing, I think. And then in application sense, of course, once the user logs in and you get the claims, you get the information, what is this person's role in the application? Or what is the group that this person belongs into? Sales division is a group or something. Then you, of course, have metadata on this person authorization in the application itself. So that hasn't changed from the classic AD. Monitoring. Application Insights is the tool you use to monitor your application, both backend and client, although in the client it is not the best one. So if you have a log rocket or something, some experience on the front-end applications that generate videos of what your users did when there's an exception, you know, what were they clicking or pushing or something, Application Insights doesn't have that. But the analytics side on Application Insights with custom query language, that's very nifty. Like if you haven't seen it, it's very good because you make these SQL-like queries into whatever web log data you happen to have from your application, and it's very performant. Then you have the Azure Monitor, which is this unified view for Azure PaaS products. So if you have Azure Event Grid or Azure Service Bus, you go to that application, you have the monitoring for that product in Azure Portal for that product. But if you go to Azure Monitor, you can view all of your products there in a unified way. You can build dashboards. That's what we do a lot. We build dashboards to service desk or help desks related to the application we built. And this dashboard shows custom events or metrics or whatever is meaningful for our application. It usually isn't the CPU. It usually is the amount of messages unprocessed if they are orders, for example. Event hubs that accepts millions of messages per second is a good tool if you want to send every exception or something else to the event hubs from all of your applications in your Azure stack. Then you can plug in Azure Data Explorer, which is an expensive product, 700 euros a month, but still, if you have the money, you can plug it in all of those messages and you can have this SQL-like query language into all the events in all of your applications in the whole corporation. So that's a unified view in my sense. And then there's the API management, which of course monitors the API calls, API requests. So here we have the whole architecture for this order master concept with searching, with diverse documents, with identity, with monitoring, with binary objects and images and all of that stuff. Multi-factor authentication, application insights, and Azure Key Vault is the secret storage. So instead of having your secrets in your CI, in your DevOps, you have your secrets in Azure Key Vault, your certificates, and your passwords and all of that, connection strings. Takeaways. Concept first, architecture second. It's good to know the Azure products, but Microsoft has a lot of documentation, so it's better to know the concept. Where is the return on investment, what you are building? Storage can be the hardest thing to change later, right? You saw the stack. Like if you do partitioning in Cosmos DB and you suddenly decide that this was too expensive, I need to change it, it's not fun. In compute, platform as a service and function as a service is the least amount of admin. Containers have their place, but this is a fact. Wrong messaging choices can halt your app. If you have an Azure Event Grid and you have one web app and Azure Event Grid sends 1 million messages to your web app, the web app will go down. And when it gets up, it will get 500,000 messages and it will go down. Platform as a service drives platform login. So when you choose the platform as a service product, realize that you are using one vendor's one product. So evaluate the return on that investment. How fast it is to use platform as a service instead of building it building your own, and how fast it is to migrate from that product to something in some other cloud or something you built yourself. On identity, please use Azure AD or Auth0 or some other provider so that you don't have to worry about GDPR and all of that stuff. Monitoring is never good enough on launch day, right? You have an application, god damn it, it crashed. We have no custom events. Nobody knows what happened. Let's look at it. And at the end of the day, just talking to people and coding. A lot of stuff, but no need to worry. Can be made to work. Get the slides and sign up. Thank you.